Hi, in this video we are going to talk about stacks and queues, so let's get started. What is a stack? Stack is an abstract data type. In Java we call it an interface, and if you are not able to make distinction between abstract data types and data structures, then it's very important to be able, because abstract data types just specify what the given data structure can do. For example, stack have a method pop and push, and this is why it's called an interface usually, because if you are familiar with Java, for example, you can have, or in C++, virtual functions, whatever, you can prototype what this data type is going to do. And for example, stack can do push and pop operation, and we are not curious how these kinds of operations are implemented. It's a typical example, for example, that we want to sort something. We have nothing to do with the concrete implementation. It can be a bubble sort, it can be a heap sort, whatever. We just don't care about it. We just want to be the, for example, array to be sorted, and this is what the abstract data types, it's something like this, that we just want to prototype what the given structures can do, and the data structure can the concrete implementation of these problems. For example, a priority queue is an abstract data type, and we usually implement priority queue with the help of a heap. And in the heap we have a concrete implementation of these problems. We are going to talk about it later in the heap section, but it's very important that you know the difference between abstract data types, or ADTs, and data structures in the main. So it has two basic operations, the pop and the push, and it has a LIFO structure, which means that the last item we have inserted will be the first that's going to pop out. In most high-level languages, a stack can be easily implemented either through an array or a linked list, and a number of programming languages are stack-oriented, meaning they define most basic operation, for example adding two numbers, printing a character, as taking their arguments from the stack and placing any return values back on stack. And if you are familiar with recursion, usually the operating system use at a very low level a stack to resolve recursion. For example, if you want to calculate the factorial, then the operating systems keep pushing the numbers or the operations to be calculated to a stack, and that's why we can get a stack overflow if you want to calculate, for example, the factorial of 1000, because we keep pushing these items, and the stack has a limited size, and we just it's going to overflow. And if an oversized data item is moved to a stack location that is not large enough to contain it, return information for procedure calls may be corrupted, causing a program to fail. And this is the basic of the so-called buffer overflow attack. If you are familiar with these kinds of hacking activities, then you definitely know something about buffer overflow. So we're providing oversized data input to a program, and such a program may copy the data in its entirety to a location on the stack, and in so doing it may change the return address for procedures that have called it, and in the end it's going to carry out unauthorized operations. So this is why we have to be very careful about stack-based programming languages. But for example, Java has the Java virtual machine operating between the program and the hardware and the software, so these kinds of problems are not so important nowadays. Let's illustrate how it works. You want to keep pushing items. I think it's very easy to understand, and we just keep pushing. We push the 88, and if we want to pop something, then it has a LIFO structure, as I said earlier, so the first element to be popped out will be the last we have inserted, and we keep popping, yeah. And last one, okay. What is a queue? Queue is an abstract data type as an interface, so it's like stack, the basic operations are enqueue and dequeue, and it has a FIFO, first in first out structure. And it's very important that it is an abstract, the queue itself is an abstract data type, and we usually implement it, the concrete data structure, with the help of a linked list. We are going to see it. It can be implemented with linked lists, as I said earlier, and it has lots of applications. We are going to talk about graph traversal. The breadth-first search algorithm relies heavily on this queue. So, how it works? We have a two-way. We can enqueue something and we can dequeue. So unlike stack, it has an entrance and an exit, something like this. So we keep inserting, we keep enqueuing 56, 88, and if we want to, if we call the dequeue method or dequeue function, we just keep getting out the first item that has been inserted, not the last. It's not a LIFO structure, it's a FIFO structure, first in, first out, and so on. If you want to dequeue again, 56 will be dequeued. Okay, so that's all about stacks and queues. In the next video we are going to implement both of them together. Thanks for watching.